This is about finding the trig values of quadrantal angles, which are the angles between the quadrants, like 0, 90, 180, and 270. When we get to those angles, we can't draw a triangle, so how do we find those trig values? Well, before I answer that question, I want to talk a little bit about similar triangles. Right here, I have a triangle that is a 30, 60, 90 triangle. And remember, I'm referring to angle 30 because that's the angle at the origin. Opposite 30 would be the side 1, opposite 60, square root of 3, and the hypotenuse is 2. So that means if I wanted to find sine of 30, for example, that would be opposite over hypotenuse, or 1/2. But let's say I wanted to have a smaller triangle and I wanted to have the hypotenuse equal 1. So if I wanted the hypotenuse to equal 1, I would have to divide everything by 2. So now my opposite side is 1/2, my adjacent side is the square root of 3 over 2, and my hypotenuse is 1. So if I wanted to find sine of 30, opposite would be 1/2 divided by 1, which is still equal to 1/2. So we talked about scaling the sides, either making them all bigger or all smaller by the same ratio, doesn't affect the trig value. Similar triangles have the same trig values. Okay, so that's what I wanted you to recall. Recall that similar triangles have the same trig values, the same ratios. So, since that is true, let's just make the hypotenuse of a circle equal 1. Or the hypotenuse, which is the radius of the circle, let's just make that equal to 1. So, I talked about before that when we were doing triangles, making our triangles in standard position, we could think of this as a triangle inscribed in a circle. So if I make a little circle here and I inscribe a triangle in it like this, and I want to make the radius 1, this is going to be a point on the circle. I'm going to call it xy, and so this adjacent side is x and the opposite side is y. Now this is a really convenient way to label the triangle, and I'll show you why. Because if I want to find cosine, so here's my angle theta, if I want to find cosine of theta, that's x over 1, which is just x. If I want to find sine of theta, that's y over 1, which is just y. And if I want to find tangent of theta, opposite over adjacent, that's y over x, which is well, that's y over x. Okay, excuse me. So that means that the coordinates of this circle right here actually tell me the cosine and the sine values. So the cosine value is this x value here, and the sine value is just that y value there. Now this special circle that has a radius of 1 is called a unit circle because its radius is 1 unit. And that's supposed to, I didn't spell circle correctly. Let's do that again. So in a unit circle, the x and y coordinates give me the sine and cosine values. That's going to be extremely helpful in finding the trig values of certain angles. So now let's take a look at some of our special quadrantal angles. So we're going to look first of all what happens when we are at 0 degrees. Okay, so we're at 0 degrees on the circle, and I want to find cosine and tangent, sine and tangent of 0 degrees. Before we do that, I want you to look at a little Desmos demonstration here. I think this will be very helpful. Okay, so here we are at 0 degrees. Now I'm going to move up the triangle up a little bit into quadrant 1. So here's our triangle. Notice here's our adjacent side, here's our opposite side. Okay. What I want you to notice is what's happening to the adjacent side and the opposite side as I move this triangle, this angle, closer to 0. So we're moving it closer. Notice as we move closer to 0, so let's do it again. So we move closer to 0, the adjacent side is getting longer, and the opposite side, the vertical side, is getting shorter. So what happens when we get all the way down to 0? Notice the opposite side here is very, very short. The adjacent side is getting really, really long. When we get right at 0, the opposite side has disappeared. There is no vertical side. the adjacent side now has become the same length as the hypotenuse. The hypotenuse, the radius of the circle, is the radius of the circle, and so the hypotenuse and the adjacent side are now equal to each other, and the opposite side is 0. So let's write that down. So right here we notice that the adjacent side equals the hypotenuse, and the opposite side equals 0. So notice here, adjacent side is right on top of the hypotenuse. So if we call this a unit circle, where the radius equals 1, write that a little better, radius equals 1, that means the adjacent side and the hypotenuse are both equal to 1, but the opposite side is equal to 0. So when we do cosine adjacent over hypotenuse, we can say this is 1 over 1, which equals 1. Sine is opposite over hypotenuse, which is 0 over 1. 0 divided by any number is 0. And the tangent is opposite over adjacent, which is 0 over 1. It's also 0. So the tangent is 0, the cosine is 0, or the tangent and the sine are both 0, and cosine is 1. Remember, cosine is the x direction. The x direction is as big as it can get. The biggest ratio that we can get for opposite over hypotenuse is when adjacent over hypotenuse is when adjacent and hypotenuse are the same number, 1. Let's go to 90 now. So I want to go back and look at my angle here. So what's happening as we move to 90? What's happening to the opposite side? It's getting bigger and bigger and bigger. It's getting taller and taller. What's happening to the adjacent side? It's getting smaller and smaller. When we get all the way up to 90, notice that my opposite side and my hypotenuse are nearly the same now, and my adjacent side is almost down to nothing. So when we get exactly at 90 degrees, notice the opposite side and the hypotenuse are both the same length. The vertical side is the same length as the radius now of the circle, and the adjacent side has gone to 0. So when we look at this straight up like this at 90 degrees, we have the opposite side equal to the hypotenuse, and if this is a unit circle, we'll call that 1, that is equal to a radius of 1. And we have our adjacent side, the horizontal side, is equal to 0. So when we do cosine of 90, we're doing adjacent over hypotenuse, 0 over 1, which equals 0. Sine of 90 is opposite over hypotenuse. They're both equal to 1, so 1 over 1 is 1. Tangent of 90 is opposite over adjacent, 1 over 0. Well, we can't divide by 0, so tangent is actually undefined at 90. There is no tangent value at 90 degrees. Okay, I think you're probably getting the idea here. We'll look one more time at our Desmos and see what happens now as we move towards 180. So notice once again now the opposite side, the vertical side, is getting smaller and smaller, and the adjacent side is getting larger and larger, but it's in the negative direction. Okay, so we talked about the hypotenuse is always a positive number because it's the radius of the circle, but can't get it to exactly 180. There we go. But the adjacent side still has this direction associated with it, so it's going in the negative direction, but it's the same length as the hypotenuse. So when we get to our 180 degrees going this way, we have our adjacent side is equal to -1, our hypotenuse is equal to +1, because it's always positive, and the opposite side is 0. So when we do adjacent over hypotenuse, -1 over 1 equals -1. Cosine of 180 is -1. And that makes sense because cosine is negative on this whole side. Okay, it's negative. Cosine is negative here, and cosine is negative here, so it makes sense that it's going to be negative at 180 also. Sine of 180 is 0 over 1, which is 0. So I want you to think about this. Also makes sense because sine is positive in quadrant 2, sine is negative in quadrant 3, so between positive and negative we need to have 0. Tangent of 180 is opposite over adjacent, so 0 over negative 1, which is still 0. So tangent is 0 at 180 just like it is at 0. Now when we get to 270, we're straight down here. Now I want you to notice when we're straight down, the vertical side is as long as it can get, so the opposite side now is negative 1. The hypotenuse is still 1, and the adjacent side is now 0 because there is no horizontal side to this. There's no horizontal direction, it's just straight vertical. So cosine of 270 would be adjacent over hypotenuse, 0 over 1, which is 0, and since cosine is negative over here and cosine is positive over here, it makes sense that it is 0 right down here. Sine of 270 is negative 1 over 1, which is negative 1. And since sine is negative in both of these quadrants, that makes perfect sense that sine would have to be negative still right here. Tangent is 270, or tangent of 270 is opposite over adjacent, negative 1 over 0, which is undefined. So both times when tangent is 0, or tangent, when we're dealing with a vertical line, tangent is undefined. When we're dealing with a horizontal line, tangent is 0. So I could probably go back up here and say here we have cosine positive, cosine negative, so it makes sense that cosine is 0 right in between. Here we have sine positive and sine is positive, so it makes sense that sine is positive 1 in between. That's the highest, that's the biggest that sine can go. Now, let's tie back what I said about the unit circle to all of this. I said if the coordinates of the unit circle tell us the cosine and sine values, then let's look at the coordinates of our quadrantal angles. So if this is a unit circle with a radius of 1, this is the point 1, 0. 1 tells me the cosine value, 0 tells me the sine value. At 90 degrees, the coordinates of the point here are 0, 1. Notice that 0 tells me the cosine value and 1 tells me the sine value. Also notice that y over x is 0 over 1, which is 0, and this is 1 over 0, which is undefined for tangent. When we go to 180, this is the point negative 1, 0. Negative 1 tells me cosine, 0 tells me sine. And 0 divided by negative 1 is tangent. When we're down here at 270 degrees, I never actually put how many the degrees on here, this is 270 degrees, this would be 0, negative 1. 0 tells me the cosine value, negative 1 tells me the sine value, negative 1 over 0 is the tangent value. So this is how you find the sine, cosine, and tangent of our quadrantal angles, the ones that are in between the quadrants 0, 90, 180, and 270.